Alright, let's begin. So we're going to talk about the grid entities, as well as mushroom explosions. So for the grid, we have an entity grid. This grid entity is a parent class for both the text blocker and the mushroom. So it has some of the things they have in common. Excuse me. The text blocker is a empty game object, or an invisible game object, I should say, because we are not drawing the sprite we store in it. So it has the sprite for a blaster. Doesn't fully matter which sprite we use, so long as it matches the size of a mushroom, which is 16 by 16. We get the bitmap for it, and we set the collider. Whenever we initialize it, we get a position, and we tell the grid to insert it at that position. So this is used mostly here when we are inserting blockers, as well as inserting the top row. So when we block the top row, we just iterate through that first row of the grid and put a text blocker in every spot up there. And what this does is it ensures that the flea and the centipede cannot create mushrooms on the row that displays all the scores, because that spot is already filled by an empty text blocker. The other time we call this is for when we insert blockers during idle play. So we can see over here with the current insert blockers, whenever we are on grid 0, which is also the idle grid, whenever we are in that state, we are inserting blockers, and this will make sure that the bullets and centipedes cannot go through any text that is on the screen. So if I were to quickly run these so we can see this in action. So we can see we are blocking the top row. So if I were to open this up and run through it, see that it's now populated with text blockers. I really should stop calling them empty. And because we are playing in attractor mode, we also have this function getting called as well. So if I run through that real quick and then go to like around here, you can see that we have the 3 initials, the 4 scores. Above it should also have 3 initials, 4 scores. 3 initials, 4 scores. 3 initials, 4 scores. 3 initials, the 5 scores. This is, oh shoot. That's the first place score. And then we also have, where is it? Is it here? No, it's here. We also have this. These represent the sentence that is created from here. So this is the press 1 or 2 to start line. So if we run through this again. So as you see here, the bullet is going in between them, but when it moves in front of the blockers, you can see that it will get destroyed because it cannot shoot through a text line. And then we can also see over here, the centipede is going to run into the text and then turn around. And then also the bullet, when it fires, it stops at the numbers as well. Okay, so that is how the text blockers are added. Whenever a player is activated, we make sure the top row is blocked, and then after that, we will iterate through the current player's board state. So from the player class, we have that boolean that shows where all the mushrooms exist. And when we activate the grid, we end up making sure that there's nothing there. So if there's something that is supposed to be in that spot and we haven't added it, that means it's a mushroom, so we add a mushroom. This is because the player doesn't fully keep track of the text blockers. They're only kept track of here and here. So because of this, if we find a space that is true here, it means that we have to make sure a text blocker doesn't exist. If the text blocker doesn't exist, then we put a mushroom in that spot. And then healing, we'll talk about in a bit. For this part, for populating the grid. So if I don't need need you. Okay, so if I run through here, so player one's gonna play for a bit, destroy some mushrooms, and then damage others, as well as we'll create a few as well. Okay, then they die. So how this function works is it is going to take the current active grid and it will iterate through it. Anytime it sees a mushroom, it is going to list it as true. So it will say that spot on the board, it is a mushroom, so make it true. And furthermore, if that mushroom is either damaged or it is poisoned, we're going to add it to the damaged mushrooms list. This list I'll cover a bit more in a second. So if I run through this, we don't care about this one right now. This is line 101. So over here we can see for row 4, column 10, this was where one of the mushrooms were added. So if we go here, we can see that it's false, but because we created a mushroom there, we have to set it to true. And it will loop through that. So once that's all done, where is the heal? So here's the heal process. So whenever a mushroom is damaged, it is added to this list. Once the board state is processed, then we start the healing and regeneration of the board. So if this is not an empty list, we will get the frontmost mushroom on there. We will create a mushroom explosion, which I'll talk about in a moment. Heal the mushroom and then remove it from the list because it's no longer damaged. So explosions are a type of object that will end themselves once they are done with their animation. So once they are on their last frame, they mark it for destroy. There are a few different types of explosions. For the mushroom explosion, this one has the sound and scores for whenever a mushroom is does its animation in the regeneration process. So whenever we initialize it, we send this sound as well as sending the score. Whenever the animation is complete, we tell the grid to move on to the next mushroom and then destroy this. So if I were to go here, we have our mushroom. It will play itself. Let me just do that so we can actually see it. So it will, once it's done, it tells itself to make the next one. So we have one here. Now we have that one started. Then it finishes, and then it will move on to the next one until it's done. Then I need to unmute it. Let me see. I gotta turn off the debugging. So if I were to continue this and then unmute it, it plays the sounds. Do it again. Like so. Okay, so that is how the explosion for the mushrooms works. And once the grid is fully processed, it tells the game master that the grid is done, and it will move on. So if the current player has no lives left, that means we have to check to see for a high score. If there's a high score, then we add inputs, which I'll talk about with the score section, and then swap players. Otherwise, we just swap players altogether. Let's see, so that's the game master. For the mushroom itself, we have its score value stored here. When it's initialized, it gets a row and column to go to, and then we set its position to be that based on the grid cell size. If the row is within the play space, we have to add it as a play space mushroom. This is something we have to keep track of so that the flea knows when it needs to spawn more mushrooms. If there are not enough mushrooms in that play space, then the flea has to spawn another one. Whenever it collides with the spider, it instantly gets destroyed. Otherwise, if it gets hit by a bullet, then it only damages itself instead. Let me pull up the bullet. So whenever a bullet collides with a mushroom, it only damages it. Whenever it collides with a text blocker, then it just destroys the bullet itself rather than the mushroom. So whenever a mushroom is damaged, its life counter is decreased. If its life is less than 1, then it prepares itself for destruction. Otherwise, it will change its frame based off of how many lives it has left and whether or not it's poisoned. And whenever the mushroom explosion plays the heal effect, we change its lives back to the max lives. Change it to max lives, and then whether it's poison, and then we set its poison back to false, and then its frame is back to frame 0. Other explosions. So in the critters, all critters except for the spider, they have a small explosion. So anytime they get collided by a bullet, they have to create a small explosion, which has this explosion update, as well as initializing itself as the 1x1 explosion and setting its frame and position. The spider and the blaster use the big explosions, which is the same as the small explosion, except it uses a different sprite. And I think that's it.